All right, we got 6.1, solving systems of equations or graphing systems of equations. Okay, it's a pretty basic lesson as long as you understand and remember how to graph lines. Okay, if we can do that, you're going to be fine. All right, so here we go. Okay, there we go. First line, definition system of equations. Any group of equations with the same variables. So now you kind of make a progression in math. All right, Algebra 2, you kind of progress through all different types of functions. You guys, you slowly progress from, order of operations to, single equation to a line. Now we're progressing to two lines. Okay, that's what a system is. Multiple lines. Okay, it could be two, could be three, could be four. We're going to mostly work with two. Okay, Clayton? Yep. All right, now if you look at that box, it's down here. This kind of is a little table of how many different types of solutions. So different than just normal graphing lines. Now we're going to have a point where these lines intersect, where these two lines cross up. That's going to be your answer, is where these lines cross. Thank you. Okay, and there's three different outcomes. Outcome number one, most common, is when you have exactly one solution. The two lines cross at one point. Option number two, you have an infinite number of solutions because those two lines end up being the same line. Option number three, no solution, because your two lines end up being what? Parallel. Very good. That middle box, that terminology, the consistent independence and stuff like that, you can go ahead and cross out. Okay, I don't worry too much about that. First example, we have y equals negative 2x plus 3. I'm going to call that my black line. The second example, we have y equals x minus 5. Call that my red line. Alrighty. Okay, let's refresh. Where do we start?
3.
On the y-axis, because that 3 is called the what?
Y-intercept.
Y-intercept. Very good. Okay, so right there. Okay, if you can see it, it's right there. Okay. Negative 2 is called my what?
Slope.
Your slope. Put it over 1, since it's a whole number. And that means we move how?
Up to the left one.
There we go. Flip them. Flip your directions. Down 2 and right 1. Okay. Down 2. Rise over run. Remember, so up and down goes first. So down 2 to the right 1. Okay, so down 2, right 1 right there. Okay. Remember what I taught you last semester. You have a negative slope, which means your line has to end up going which direction? Downhill. Right? Has to go downhill. So make sure your dots line up so you go downhill. Okay. Keep moving in that manner. So down 2, right 1, down 2, right 1. How else could you move? Up 2, left 1. Take your straight edge. And straight line it. All right, the red line, y equals x minus 5. Where do we start that guy? Negative 5 on the y. So 1, 2, 3, 4, 5 right here. How does it move? What's its slope?
Uphill.
Okay, it's uphill. It's positive. That's good. But what's the actual slope? Bertelsmann. 1 over 1 or just 1? All right, slope is 1. So you move up 1, right 1. Up 1, right 1. Up 1, right 1. Okay, right there. What's the solution here then? Isaiah.
One solution.
One solution, but what is it? Or let's do this first. Where is it? Easier than that. It's where the two lines what? So the two lines intersect, which is going to be about right there. All right. Now, that's an ugly intersection. That's a poor color choice. Hang on. There. Now you can see it. Right there. Okay. Now, this is a poor example, just especially for our first example, because it doesn't cross out nice. Most of yours will cross nicely. Okay. Actually, all of them from here out should. All right. So I'm going to go ahead and tell you this one. You go to the left. Let's see. It looks like it goes to the left. 1, 2, about 2.5, and then down 2. So your answer here would be 2.5, -2. All right. So we have one line being y equals -2x minus 5. The other one being y equals -2x plus 3. Okay, so I'm going to kind of go through this one just a little quicker. The first line, your black line, start at -5. And then we're going to move down 2 and to the right 1. Can also move up 2 to the left 1. And draw that line. Okay. And the red line, we're going to start at +3. And how are we going to move there? Downhill, how so?
Down to the right one.
Down 2 and to the right 1, which is what compared to the last line? The same, which means these lines are what? Parallel. Okay, now hopefully you saw that before we started graphing. Yes, I do want you to graph these even if you do notice they're parallel. Okay. But what's your solution then? None. Okay, because the solution to a system of equations is where the two lines intersect. Do parallel lines ever intersect? No. So if they'd never intersect, you can't find the solution. All right. Nope.
Oh.
1 for 3. Now, 2x, next example, we have 2x minus y equals -1. We have 4x minus 2y equals 6. Does anybody, I barely mentioned this last semester. Does anybody know what form of line this is? I barely mentioned it, so if you don't, it's okay. No. Starts with an S.
Straight slope form?
No. Standard. Okay, it's called standard form. I absolutely hate standard form. I think it's pointless. What do I want you guys to change it to? Slope intercept, which means you solve for what? Y. Very good. All right, so the first one, we're going to solve for y. So I'm going to work this guy out here. What's the first step in order to solve for y? What do we got to do first? Bertelsmann. Subtract 2x. So don't forget the negative that's in front of that y. It's very important. So -y equals -2x minus 1. Dalton.
Then you divide by the negative.
Divide by the negative. Very good, sir. All right, which gives you, I'm going to kind of work it this way. 2x plus 1. You do the second one. All right. Okay, so for the second line, what's your first step? To solve it. Subtract 4x. So you get -2y equals -4x plus 6. And then divide by -2 all throughout. So you get y equals 2x minus 3. Okay, and you notice what? Same slope, so I'll expect you guys to graph these, but what's our answer going to be? No solution. So then moving on to the last example, and the only thing hard about the last example is kind of just a refresh of something that we've talked about. You still have to solve that first guy, okay? So I'm going to do that kind of real quick. 2x minus y equals negative 1. We subtract 2x, so you get negative y equals negative 2x minus 1. You divide through by that negative 1 to give yourself y equals 2x plus 1. You started at 1 on the y-axis, which is right there. You move up 2 and to the right 1. Then we bring it down this way as well. All right, the point of this, or the thing of this problem we had to refresh is the y equals 3 line. All right, that's the one that we haven't seen yet. It has been a while since we've seen. So y equals 3. Remember how we did this the very first time, what we did? I believe is Isaiah sent up to the board. I said, show me where y equals 3 at, and you said y equals 3, let me guess. You said right there.
Did I?
I think so. I have a pretty good memory, so I'm going to say yeah.
Okay.
Okay, and I'm pretty sure I sent Dalton up next. I'm pretty sure he said, well, y also equals 3 right there. I'm pretty sure Wilson was after that, and we said here. And then we just finally figured out, well, it's just going to be what type of line?
Straight line.
Horizontal line. There you go. Horizontal line where y equals 3. What if it was x equals 3? Then what type of line would it be? Vertical. Very good. Okay, so that's just to kind of refresh that topic. It stays with you, but it's also one of those things that sometimes it doesn't get talked about too often. Okay, so keep that in the back of your mind. There's a couple of that like that on your worksheet. But kind of after this, it kind of goes away just a little bit after this chapter. So keep that in the back of your mind when you go into geometry and then when you come back with me in Algebra 2. So once again, the solution is where the two lines cross, which will be right there. And that point is to the right 1, and then it's up, up 3. So 1, 3.